right, y'all. We're going to do physical and chemical changes. Mainly in this unit, we're going to go ahead and look at the evidence of chemical changes, what pieces of evidence you would see. We looked at this a little bit when we burned our paper in class the other day. So, moving into the second slide, and you should have your notes open and you should be completing this, but you're going to reflect on these questions before we go ahead and look at our notes today. So, if you were quizzed today, what parts of the question would you already know the answers to? So, right here, an essential question to begin with is how does evidence of chemical reactions indicate that new substances with different properties are formed? So, think about even if you use the example from the other day of us burning the paper, what pieces of evidence determined that paper was formed into a new substance? What kind of things did we talk about in class? So go ahead and type your answer in here where you see my cursor. Okay? Down in the second question here, when you're ready, okay, of course, pause the video to type, and then when you're ready, move on. But which parts of the question, like which parts right now between physical and chemical changes, are you kind of confused about? So go ahead and answer that. Um, all right. So after you're done with the questions, then, start the video up and move into this slide. So we're going to be starting to look at chemical changes. Um, but what first occurs and what we were talking about when we went into the topic of elements, when two or more elements combine, they're going to form a brand new substance with new properties. That's because a chemical reaction occurs to break down those atoms and create new molecules into something completely new, such as we talked about um, that sodium and chlorine combine chemically and create a whole new substance with new properties, and that's salt. Okay, so again, a chemical reaction, this occurs when two or more molecules interact and the molecules change into a new substance with new properties. Bonds are broken up between the atoms and create new molecules. So, looking at this picture here, what do you guys notice about the molecules before and after the chemical reaction? So, what do you notice before? And then this arrow means the chemical reaction is occurring. And then you have this. So, you can see that we still have the same number of the little white circles. We still have a gray one. We still have two red ones here and two red ones here. But if you're thinking in your head it's all like different and differently shaped and they're in different orders and whatnot, you'd be right. So, write kind of what I said just now, that in your own words, type in here what you notice about this picture after the arrow. Okay, so this tells you a chemical reaction is occurring because, I mean, look at it. It's the same amount of circles, but I mean, in the picture, you also have everything is all jumbled up and mixed up and in a different order. Okay. So now we're going to go ahead and move into, once you're done typing, start the video again, and you can move into physical and chemical changes. So, physical change, we know from talking about the paper when I ripped it in half, that was just changing the appearance. It did not change that paper into a new substance. Some examples of physical changes are whipping eggs, boiling water, dissolving sugar. This is the one I told you that kids get confused on because um, when you have like the lemonade packets or Crystal Light or even just plain old sugar, hot chocolate, whatever it is, Kool-Aid, and you mix it up in water, if you were to let that water evaporate, you'd be left with the crystals at the bottom. It looks a little different, but nonetheless, there's still those crystals. So that is just a physical change, okay? Dicing vegetables. So words like this, whipping, boiling, dissolving, dicing, if you hear words like that or tearing, that could be examples of physical changes, okay? So you have to name one more example of a physical change. If you can think of one, go ahead and put it on there. Even the paper example we did the other day, okay? I gave you even an example of dissolving sugar. I said Kool-Aid. Um, some kids, even though you might be whipping up eggs and stuff, please remember it's still eggs. We are not in the process of taking all the ingredients, putting it together, and baking just yet. It's just whipping eggs in this example, okay? So, right here, you're just gonna go ahead and type in an example of a physical change that you can think of. All right? So, take your time to do that and pause, and then we'll continue. For the purpose of the video, though, I am going to move on to the next slide. So, when you're ready, you can push continue. So this question is for, what do you think? What is the main difference between a substance going through a physical change and one going through a chemical reaction? So go ahead and put your thoughts in here. Your thoughts should be based off what we went over in the previous two slides, okay? So for a physical change, we're just altering the appearance. That's about it. We're not creating a new substance. When you're going through a chemical reaction, you're going to have, again, everything's kind of broken down and then rebonded into a new pattern, which makes a whole brand new substance. Okay? So here's a question down here. So you could then type that in. And then number 2 down here, you could put this one is, why is making fruit popsicles a physical change? Well, think about it. If you're making popsicles, whether you're using soda or juice or actual fruit, you're just cutting it up or pouring the fruit into the little molds. You're not really altering the appearance. You're not really altering and making it a brand new substance. You're just altering the appearance and making that liquid that you poured or the fruit that you diced up, you're freezing it. So you're turning it into a solid. The fruit that you diced up, you probably put in with a liquid of some sort, and it's still going to freeze and you're going to have that solid. But if you were to kind of let it sit out, it would remelt. All right. When you're done typing all that in, then move on to the next slide. Right here, physical and chemical changes. Unexpected color change. Well, for when you have an unexpected color change, we're just going to read this real fast. New molecules created in a chemical reaction radiate light differently, producing new colors. So, such as burning. All right, we talked about that when we were burning the paper. That is a color change. All right, that's going on. You also have an example here, fireworks, and then leaves changing from green to orange and red in the fall. In this picture, you will have a color change. This is when you have two liquids. So what they're dropping into this one liquid here, they're two different liquids. Okay, I don't know what it is based off the picture, but it's when you put two liquids together and it forms a solid with new properties. And you can see it's yellow. What they dripped in was not. What they're dripping into it is not, but it's creating a new color, new properties. It's a solid. This is a vocab word. This is something known as a precipitate. All right. So again, we're going to go ahead and move on. Physical and chemical changes. And here's another piece of evidence here. So an unexpected temperature change. So during a chemical change, you can have a temperature that is changing, such as when we burned the paper. Um, that wick is obviously going to be very hot because it's burning compared to the surroundings, like where we are, which is cooler. Another example would be adding baking soda to vinegar, causing the temperature to decrease. And and body temperature right here increases to fight infections. So those are all going to be chemical reactions. So in an unexpected temperature change, meaning it just changes, we weren't really expecting it at all, such as the baking soda and vinegar, there is a temperature change where this gets really cold. And the body temperature, when you're sick and your body's fighting off the disease or the infection, um, your body's going to increase in temperature. Hence, you don't feel good, okay? But it's a good thing because your body's fighting it off. So, in a temperature change, what in an unexpected temperature change, what causes that temperature to change? So, pause the video and type that in. The answer is really on the slide here, off to the right. So, what you should be typing in is, when there's chemical bonding, energy is released or absorbed, making the surroundings hotter or cooler. All right, so you should be typing that in here because you could be asked that type question on a test, and one of the answer choices could be just random stuff or something in here that makes the statement false. And then I'll copy and paste this and put it in. And hopefully you have that typed in because you will be turning in these notes. Alrighty. When you're ready, you can kind of move to the next slide. Physical and chemical changes, combustion and burning. So this is a chemical reaction. So this is going to be similar to what we did the other day. Lighting a candle, could be rusting, could be wood burning. So this is a reaction that's going to happen between substances, usually including oxygen and giving off heat or light. So usually rusting is going to occur outside a lot of the time, like whether it's a fence or a bike or certain things that were left outside because mix the oxygen outside and the sun and weather that happens can cause rusting to occur quickly. So this can't be undone. You can see the wood burning, or if you ever have a fireplace at your home or whatnot, that wood really can't be reused if you used all of it because it's going to go turn into ash. Same thing with the match. For those of you who've ever used a match or seen a match being used, you can really only use it one time. Chemical changes again, we're gonna have that precipitate. I mentioned this in the other picture. In this one here, they put in this little rod thing and it had something on it, but this liquid, I think they went ahead and put dye in it. Not positive because it's just a picture. But this is when a solid appears in a solution. Okay, so a solid appears in a solution. So again, it's a solid that suddenly appears. All right. Examples, milk souring. If you've ever seen milk and it has those chunks in it, your milk is a very, very expired and it smells terrible. So it's going to have the solid chunks in it. So that's souring. And certain bathtub rings, if you've ever seen that, if your bathtub is like, dirty or whatever, you can get bathtub rings. But a great example, I always go to milk souring. So, how can you tell that a precipitate has formed? So go ahead and answer that. But the answer again is usually on the slide. It's when a solid suddenly appears in a solution. So really a solid appears in a liquid, if you will. Kind of crazy, right? Another piece of evidence of a chemical change is when you have bubbles forming. If you've ever seen those commercials or even done it where you put an Alka-Seltzer in liquid and it's going to make tons of bubbles. Okay. So that's when gases are produced. Bubbles released when vinegar and baking soda are combined. Vinegar and baking soda, when they're combined together, they can make bubbles. Alrighty. So bubbles will form. So in the little think about it area, Betty and her grandson decided to bake a cake. They gather eggs, flour, sugar, salt, baking soda, oil, and vanilla. All the ingredients are measured and mixed following Betty's grandmother's recipe. Did they bake the cake in the they baked the cake in the oven for 30 minutes? Did the ingredients undergo a physical change or a chemical reaction? How do you know? Well, I always tell the kids, you should really memorize it. When you're baking something, it is going to be a chemical change. Reactions are occurring. So we can go back into these pieces of evidence that we have learned about, such as on this slide, an unexpected color change. So if they're baking a cake, you're going to have it turn to a pretty golden color in the oven. There's going to be a temperature change in the oven that's occurring. There's also going to be gases that will be released, even though there's no bubbles. You still have bubbles in the bread, and that's oxygen. Okay, they're escaping really, getting into the bread and escaping, and um, uh, gas is being released even in the oven, in that convection oven, really. Um, let's see what else. Combustion. I mean, it's not gonna be a flame per se, but you're still gonna have that oven with the heat. Precipitate. We don't really have that in there, but we have enough. I mean, we're making a solid pretty much from the liquids, but you can tell we have enough going on with our pieces of evidence that will tell you that baking something is going to be a chemical change always, okay? You're putting all those ingredients together and you're creating a brand new substance with new properties. Don't look like those eggs anymore. It doesn't look like any of that with the flour and whatever else ingredients, the sugar, salt, flour, baking soda, oil. It's all mixed together and it creates this pretty cake with brand new properties. Alrighty. The only thing I wanted to say was that I kind of missed this slide, but I mean, for chemical changes, we just went through the slides that are all those pieces of evidence, okay? But you're gonna have some examples of just chemical changes will be anytime something's rusting or like silver tarnishing, similar to rusting, but it's on silverware, um, like forks and knives and stuff. Gas burning, so like right here on the stove, if you have that type of stove. Eggs cooking anytime you're cooking, not just baking. Anytime you're cooking is going to be a chemical change. And then bread rising. Okay, bread rising is a chemical change. What you're going to do and what we'll go over on Friday will be this slide. If you scroll back up a little bit, this slide. Um, you're going to find the evidence for physical changes and place them in the test tube. You can like turn these and stuff if you want by clicking on these little boxes, but you don't have to turn them if you don't want to. You can just kind of put them on the right test tube. So you can see these are all physical changes, but you're just moving the ones that are physical changes to, there should be 1, 2, 3, 4, 5 physical changes in this list. And then you should only have chemical changes over here in the red box. So it says then the ones in the red box, what do you think the remaining cards are evidence of? You either type in physical or chemical change here. So when I see you on Friday, we'll go over this page and then really this page and kind of just answer the ending question. So if you want, you can kind of work on the rest of your notes, this page, when you're done with the other one, and read the directions here, and then you can answer the last two questions. Alrighty. Um, so write the short definition for physical and chemical changes. You can go back in your slides and type that in here. And then you're sorting these out. You're putting them in the right spot. So like we got you started. So the rest of these you'll move to the right spot under physical or chemical changes. And we will go over that and answer these ending questions. And we'll go over everything on Friday, just those last like 3 or 4 slides, and then introduce your project.